Hello class, these are your notes on section 4B, so we're in topic 4 section B, which is ordered pairs. This corresponds to 4.2 in your syllabus, so here's what we're going to be looking at in these notes. And so we're looking at this idea of relations, and let's start by thinking about a set of axes. We're going to label them A and B and go from 1 to 6, and then we're going to think about our relation by relating A to B in such a way that we want the points where A is greater than B. So I'm going to make some axes. All right. I call this one A, this one B. 1, 2, 3, 4, 5. 6. Here's my b-axis. All right, so I can think of this as a grid, and all the points where A is greater than B, well, 1 is never going to be greater than any of those numbers, so this is not going to be true. 2 is greater than 1, 3 is greater than 1 and 2, 4 is greater than 1, 2, 3, 5, and then 6 is greater than every number except for 6. Let's line these up. This 4. All right, so hopefully you've drawn yours a little bit neater than I have. But what we've got here, we could think of two sets. So we could think of set A here as 1, 2, 3, 4, 5, 6. And of course, that's equal to set B as well. And we could say that A cross B is the Cartesian product. So Cartesian product, I don't know if you've been told this before in your math classes, but when we look at our set of X and Y axes is what we normally call them, and that's the Cartesian plane. So here, A cross B is the Cartesian product, and what that's going to be is that's going to be the set of all points A and B. So our Cartesian product is the set of all points A and B, where A is an element of set A, and B is an element of set B. To write this out fully in set builder notation, we would say A cross B is equal to all those points such that, so instead of a comma, I'm going to make that such that A is an element of A, B is an element of B. So the Cartesian product is going to represent all the points over here. So we're going to have all 36 points. Yeah. If we had smaller sets, so for example, if we had a different set, let's say G was a set 1, 2, and H was a set 2, 4, 6, then G cross H would be 1, 2, so I'm going 1, 2, 1, 4, 1, 6, 2, 2, 2, 4, 2, 6. But H cross G would be different. So H cross G would be 2, 1, 2, 2, 4, 1, 4, 2, 6, 1, 6, 2. So both of these Cartesian products have 6 points, but they're 6 different points. So in general, A cross B is not equal to B cross A. In our case, here, they would be the same because A and B are exactly the same. Yeah? So really, A cross B is the same as saying A cross A here because A and B are the same. But in general, A cross B and B cross A are not the same. All right, so back to our example here. This you have seen before, I'm sure, with dice. So if we would think about each of these sets standing for a dice, we've got our special points here, where A was greater than B. We've defined a relationship between A and B. We've related A and B. So a relation has a rule that connects an ordered pair, and we have our notation for a relation. So our relation here is that A is greater than B. The way we note that is that A is related to B, and in such a way that A is greater than B. Yeah. So if we look at this, we could list all these individual points. Yeah, but we've got them here, so I'm not going to list them out. We could further separate these points by looking at these specific columns or specific rows. Yeah. So if B is equal to 1, then the certain A values that match it are 2, 3, 4, 5, and 6. And we always want to look, when we're talking about separating it out further, we look at the second value. So if we look at all the points where A is related to 1, that's the same as looking at, we could use this notation of 1, or we could put a line over 1, or we could put a dot over 1. And all of those are going to be the A values, where A is an element of A, and A is related to 1. So in this case, that set of values is going to be 2, 3, 4, 5, and 6. Because these are the values that are all greater than 1 in our set. Similarly, we could write out 2. That's going to be, if we look when B is 2, our A values are 3, 4, 5, 6. So this is a specific subdivision of our relation. Yeah? We call these subdivisions the equivalence classes. So the equivalence class, X, or we could use these other notations, X bar, X dot, those are all going to be the set of A values where A is an element, such that and A is related to X. So it's basically going through our set, fixing the second coordinate, and finding all of the first coordinates that are possible. So we would have 5 equivalence classes if you don't count the empty set. We could go all the way up to 6. So A is related to 6 up here. That's the empty set. So we could also list that. All right, so here we've talked about Cartesian product, relation, and equivalence classes.